Welcome to this lesson on aqueous solutions. Today, we'll explore one of the most important types of solutions in chemistry, solutions where water acts as the solvent. Water is often called the universal solvent because of its remarkable ability to dissolve so many different substances. Understanding aqueous solutions is fundamental to chemistry, biology, and many real-world applications. An aqueous solution is a homogeneous mixture where water acts as the solvent and dissolves one or more solutes. The term aqueous comes from the Latin word for water. In any solution, the solvent is the substance that does the dissolving, and it's present in the larger amount. The solute is the substance being dissolved, and it's typically present in a smaller amount. When we mix salt and water, water is the solvent and salt is the solute. Let's break down the two key components of an aqueous solution. First, we have the solvent, which is water, represented by the chemical formula H2O. The solvent is the component that does the dissolving work. Second, we have the solute, which is the substance being dissolved. The solute can be a solid, liquid, or gas. When these two components mix uniformly at the molecular level, we get a solution. Water is an exceptional solvent because of its unique molecular properties. First, water is a polar molecule with partial positive and negative charges on different parts of the molecule. This polarity allows water to attract and surround ionic compounds, pulling them apart into individual ions. Second, water can form hydrogen bonds with polar solutes, which helps dissolve them. These properties make water incredibly effective at dissolving a wide variety of substances, earning it the title of universal solvent. Let's look at a common example: sodium chloride dissolving in water. Sodium chloride, or table salt, is an ionic compound in its solid state. When we add it to water, the sodium chloride separates into sodium ions with a positive charge and chloride ions with a negative charge. We indicate that these ions are in aqueous solution by writing a Q in parentheses after each ion. This process of separating into ions is called dissociation, and it's a characteristic behavior of ionic compounds in water. Solutes can be classified into two main categories based on their ability to conduct electricity when dissolved in water. Electrolytes are substances that conduct electricity when dissolved. This includes ionic compounds like salts, as well as acids and bases. When these substances dissolve, they form ions that can carry electric current. Non-electrolytes, on the other hand, don't conduct electricity when dissolved. These are typically molecular compounds like sugar and ethanol. They dissolve as intact molecules rather than separating into ions. The process by which water dissolves substances is called solvation, or more specifically, hydration when water is the solvent. During hydration, water molecules surround and stabilize the dissolved ions or molecules through attractive forces. For ionic compounds, the partially negative oxygen atoms in water are attracted to positive ions, while the partially positive hydrogen atoms are attracted to negative ions. This surrounding and stabilizing action keeps the solute particles separated and evenly distributed throughout the solution. Not all substances dissolve equally well in water. The solubility of a substance depends on its chemical nature. Polar and ionic substances generally dissolve well in water because water itself is polar. Non-polar substances, like oils and fats, don't dissolve well in water. This behavior is summarized by the principle, like dissolves like. This means that polar solvents dissolve polar solutes, and nonpolar solvents dissolve nonpolar solutes. Water, being polar, is excellent at dissolving polar and ionic substances. Aqueous solutions are everywhere in nature and daily life. Ocean water is an aqueous solution containing dissolved salts and minerals. Blood plasma is an aqueous solution that carries proteins and electrolytes throughout our bodies. Soft drinks are aqueous solutions with dissolved sugar and carbon dioxide gas. In medicine, intravenous solutions are carefully prepared aqueous mixtures of electrolytes used to treat patients. These examples show how essential aqueous solutions are to both natural processes and human applications. Let's summarize what we've learned. Aqueous solutions are essential in chemistry and biology because water's polarity makes it an excellent solvent for ionic and polar substances. Water's ability to dissolve so many different substances makes it crucial for chemical reactions, biological processes, and countless applications in our daily lives. Understanding how and why water dissolves different substances helps us predict and control chemical processes in nature, industry, and medicine.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.